Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. In this lecture, let us discuss everything about thermodynamics
based on HSTR syllabus, and this class would surely be useful for KVS aspirants as well, and of course it will be useful for the CRIS aspirant also. And before starting the class, I would like to give a gentle reminder: please do subscribe to my channel if you have not subscribed still, and also if you are liking my work, please like my videos, because this channel is dedicatedly there for teacher recruitment examinations preparations, and you will find many classes based on HSTR syllabus, physics, maths, chemistry and biology. Okay, so let us start the class, and first let us have a glance on syllabus of thermodynamics of HSTR.
The chapter thermodynamics has this syllabus: heat and temperature, meaning and differences, different scales of measurement of temperature and interconversions, laws of thermodynamics, isothermal and adiabatic process, reversible and irreversible process, heat engines, different types, petrol and diesel engine, efficiency of heat engine, problems based on this, then principle and working of refrigerator. Friends, if you watch this lecture patiently, the full lecture right from beginning till end, then I assure you that you will be able to answer any of the questions asked from this chapter. Okay. Also, I have segregated as many as multiple choice questions, the 1 mark questions based on HSTR and CRIS. So please patiently watch this lecture and also make notes as much as possible, and wherever numericals are coming, try to solve them by yourselves by pausing the video. Once you see one type of numerical, then pause and then again try to solve it by yourself. Or else you can also do this way: first watch the entire video, then again come back, forward the lecture till the numericals, pause it, then again try to solve it by yourself. It is your wish. But I would suggest you that whenever you are watching this video, please try to prepare for this chapter at the same time. Just don't watch the video and leave it like that and feel that I will prepare it later. That will not help you. Okay, that is mere waste of time. So if you are watching the video, better you take notes and pen, then you note the points which you feel are important. Actually, each and every point which I am talking in this lecture or any other lecture, it will be important, because see, I segregate all points keeping HSTR and CRIS in mind. Okay, same syllabus it may have for higher classes also, isn't it? Same syllabus it may be for lower classes also. But then we will need to follow certain standards for HSTR and CRIS. Okay, that I catch that standard and then I try to explain or discuss all those points in my class. Okay, this is the procedure I follow every time. Actually, in this lecture, I have planned to finish the whole chapter, the entire chapter in this one lecture. Believe me, you will not get bored if you watch the lecture carefully. So, let's start the class then. Now, let's start with the basics, the heat and temperature. Now, what is heat? If you want to define heat, then it is the sum of kinetic energies which is contained by the molecules present in that object. If you are talking about the object which is having certain heat, then that heat will be equal to sum of the kinetic energies of the molecules which are present in that object. Okay. Now, what is the SI unit of heat? It is joules, and in CGS system, the unit for heat is calorie. There is a relation between this joules and calorie. 1 calorie is equal to 4.2 joules. Okay. Now, when I say that heat is equal to sum of kinetic energies, then I mean to say that heat is proportional to the kinetic energy, or it is equal to kinetic energy, isn't it? Now, what is this kinetic energy? Now, this kinetic energy, this is equal to half mv square, isn't it? Where what is m? M is the mass and v will be the velocity of the molecules. Thus, the reason why I can also say that the heat of an object is directly proportional to the mass of the molecules, the sum of the mass of the molecules present in that object. Or in short, we can say that heat is directly proportional to the mass of the object. Okay. Now we told that 1 calorie is equal to 4.2 joules, right? So this number is very, very important. You need to use this value if you have to convert the heat energy into calories or into joules. If one value is given with certain unit, you can convert it into other unit. For example, if you have this question, how many calories of energy corresponds to 28.4 joules? Here they are asking you energy in calories. They have given you energy in joules. So what you do? First you know that 1 calorie is equal to 4.2 joules, isn't it? Now you can cross multiply it, isn't it? X into 4.2 will be equal to 1 into 28.4, or X will be equal to 28.4 upon 4.2. Now if you cancel this number, you will get 6.4. It will be around 6.4. So this is 6.4 calories. Okay, this is how you can convert. Or in other way also they can ask you. They can ask you like this. Express 34.8 calories into joules. In this case, what you do? You know that 1 calorie is equal to 4.2 joules, right? Now they have given you 34.8 calories. You have to convert it into joules. So you put it as X. X will be equal to 34.8 into 4.2. This will be equal to around 146 joules. Okay, so this is how you can convert energy with different units. In first case, they asked you to find the energy in calories. They had given you it in joules. In that case, you divided it, isn't it? You divided 4.2 with that joules. And then in the second case, they have given you energy in calories and you have to find in joules. In this case, you multiplied 4.2 joules with the given calories of energy. Okay. So I am giving you two types of examples. In one case, you are dividing 4.2 and in the other case, you are multiplying 4.2. This is how you can convert energy from calorie to joule or from joule to calorie. So in short, heat is nothing but the sum of the kinetic energies. Heat is a type of energy. Okay. So this is all about heat. Now let's see what are the effects of heat on an object. Effects of heat means what does heat do to an object. For example, it can change the state of matter. Isn't it? If you boil some water, maybe that water will get evaporated and that water is converted into gas also, isn't it? So here there is a state change. There is a change of state of this matter. Then it can change the temperature of an object. Obviously, if you are heating it, then the temperature will change. We will talk what is temperature also now. Okay. Then heat changes the solubility of a substance. It changes the size of an object. It changes the color of the body and it also changes the volume of the body. So these are all the effects which heat can put on a substance or a matter or a object. Okay. Now let's talk about its friend. Its friend is temperature. It is not the same as heat, but it is a close friend, I can say. Temperature means it is nothing but the degree of hotness or coldness of an object. Okay, it is one thermal condition actually. It is one thermal condition which will determine the rate of flow of heat from one body to another. Either you say it like this or in simple words, it is the average kinetic energy of the molecule, one single molecule in that object. What was heat? Heat was the sum of the kinetic energies of the molecules present in that body. We were talking about all the molecules present in that body. But temperature is just the average kinetic energy of the molecule, one molecule. Now, how do we measure this temperature? We measure it with a thermometer, right? That thermometer will have different scales, right? So, we have different scales for different temperature. And each one will have lower fixed point and upper fixed point. They will have different units. each temperature will have different unit. For example, if the temperature is of centigrade scale, then the lower fixed point will be 0 degrees centigrade and upper fixed point will be 100 degrees centigrade. Similarly, for Fahrenheit scale, lower fixed point will be 32 degree Fahrenheit and upper one will be 212 degree Fahrenheit. And the same way for Kelvin scale also. For the lower one is 273 Kelvin and the upper fixed point is 373 Kelvin. So you have to remember that there are three types of scales which we use in a thermometer. That is centigrade, Fahrenheit and Kelvin scale. You should also know their lower and upper fixed points. Anything can be asked as a MCQ in your examination. Now after talking all about heat and temperature, let's know what is the difference between heat and temperature. We told that they are close friends, right? But they are not the same. Now first difference will be that heat, it will be the sum of the kinetic energies of the molecules inside that object, whereas temperature will be the average kinetic energy of a molecule. Then if we talk about the SI unit, then SI unit for heat is joule and for temperature it will be Kelvin. If we talk about all the units, then for heat it is joules and calories. For temperature it is Fahrenheit, Celsius, Kelvin and all that. And what are the symbols we usually use? For heat we use capital Q and for temperature it will be capital T. Now because we told that heat is equal to sum of the kinetic energy of the molecules, we can also say that it is the measure of number of atoms multiplied by the energy possessed by each atom. Because we are talking about the sum of the atoms, right? But here in temperature it is not like that. It is like a level which will determine the direction in which the heat will flow. And then it is related to how fast the molecules within substance are moving. Because we are talking about the average kinetic energy, right? How much fast the molecules are moving, we can calculate the average kinetic energy based on that. That will give you temperature. Okay. And we also told that heat is nothing but energy, right? Energy means the ability to do work. But temperature, it is not energy. It is just a degree of hotness or coldness. It can be used to measure the degree of heat. Okay. So you cannot know whether the body is hot or no if you don't measure the temperature. That is how it is. Okay. So heat and temperature, they are always friends. They will be together. If heat will increase, temperature will increase. If heat will decrease, temperature will decrease. Now you can change this temperature units. You use this table and you can convert Celsius to Fahrenheit, Celsius to Kelvin, or Fahrenheit to Celsius, or Fahrenheit to Kelvin, or Kelvin to Celsius, or Kelvin to Fahrenheit. Using these relations, you can convert them. Okay, we will do numericals based on this. So you will learn it by yourself while practicing the numericals and all that. These are very simple things. Before doing the numericals, I want to tell you one important point. I will tell you in a form of a MCQ. The MCQ is, what is the value of the absolute thermodynamic temperature scale? So there is one absolute value for thermodynamic temperature scale. That value is 0 Kelvin. So remember, this 0 Kelvin is the absolute thermodynamic temperature scale value. Whenever you have this term absolute temperature, they mean to say that they are talking about 0 Kelvin. You have to remember this. Okay.
Now let us discuss how to do interconversion between temperatures. Okay. See, I have one relation, this one. If you are given one temperature in degree centigrade, then how do you convert the temperature in Kelvin? You just have to add 273.15 to the degree centigrade value. You will get the Kelvin temperature value. Okay. Now you can also ignore this decimal thing, 0.15 you can ignore. Just remember this 273. So if you add 273 to the given degree centigrade value, you will get Kelvin temperature value. Okay. Like this only, you have a few more interconversions. I have table, no, just now I showed you, no. Before that table, I have one trick to show you. This is giving you the relation between different temperature scales, the centigrade, Fahrenheit and Kelvin. See this, C minus 0 upon 100 is equal to F minus 32 upon 182. This is equal to K minus 273 upon 100. Now, in the denominator, if you observe carefully, all are even numbers, right? So you can further simplify this and you will have one simple relation which you can use as a short trick in the examination. It is this. If you approximate the denominator of middle term, that is 182, you can write it as 180, right? Now if you then cancel all the three denominators with 2, you will get 50, 91 and 50, right? In the middle though 182 we have approximated as 180, right? So you will get 90. So you will get 50, 90 and 100, right? So that zeros also will get cancelled. So after simplifying the denominators, I mean the cancellation of denominators, approximately making 182 to 180, you will get this one. The relation is C by 5 is equal to F minus 32 by 9. This is equal to K minus 273 by 5. So if you remember this relation, I am sure that any question asked between the interconversions, no, your answer will go correct. If it is related to Fahrenheit, you can convert it into Kelvin. If it is related to centigrade, you can convert it into Kelvin. If it is related to Kelvin, you can convert it into centigrade, correct? So you can do interconversion using this short trick, okay? So now we have this as usual table, right? This is the one which I already told you. We can use this table to do more interconversions, okay?
Actually, using this only we have made that table also. Either you remember that table or you remember this. But then if you remember that table, you can save time in your exam. Okay. So this is one important relation. The root relation is this actually. Now let's solve the numericals based on this. First question is, what is 30 degrees centigrade in Kelvin? As I told you, you have to just add 273 Kelvin. If you add this 273 to this 30 degree, then you get the value 303 approximately, which is in Kelvin. Okay. Next question. Convert 50 degrees centigrade to Fahrenheit. Now, if you want to convert 50 degrees centigrade to Fahrenheit, what you do? You use this formula. C into 9 by 5 plus 32. This will give you the temperature in Fahrenheit. Here you have 50, right? So you have to multiply that 50 with 9 by 5 because this is our C now. This 50 will become C now. This 50 into 9 by 5 plus 32. Here 5 will get cancelled. With 50 you get 10. 10 into 9 will become 90. 90 plus 32 will be 122. This 122 degree Fahrenheit is the answer you are getting. Okay. So you have to remember that degree Fahrenheit is equal to degree centigrade into 9 by 5 plus 32. Next, convert 113 degree Fahrenheit to Kelvin. What you do here? You use the table. What is the formula here? You want to convert the Fahrenheit into Kelvin, right? This is the Fahrenheit. Now you have to convert it into Kelvin. So this is the formula you have to use. F minus 32 into 5 by 9 plus 273.15. Just to substitute the values. Write 113 in place of F and then you simplify, you get the answer. Here it is approx equal to 318 Kelvin. Okay, next question. Convert 225 Kelvin to Celsius. We converted Celsius into Kelvin by adding 273, right? Now what you do? You have to subtract it. You have to subtract K minus 273. Then if you subtract it here, in this case it is 225 minus 273, you will get the temperature in minus. You will get a negative temperature, minus 48.15 degrees centigrade. Okay. See, actually I am not giving here as MCQs because we are just discussing, right? We are discussing the problems. In your exam they will ask you as MCQs. But there also you don't see the MCQs. You just calculate the answer and whatever answer you are getting should be present in MCQs. Okay. In numericals you don't take risk of seeing the MCQs. You solve the MCQs, you match it with the number present in the answer. Okay. That is the right procedure to solve the numericals, especially in this chapter. Okay. Next question. The temperature of an iron rod is 350 Kelvin. Its temperature in degree centigrade is. See, this question I am not going to solve. You have to answer this question. This is an assignment for you. Okay. You can comment it in the comment section. I'll be glad to know your answers. I am giving you hint. The table. The table itself is the hint. You have to find the relation which is required for this numerical and then you have to calculate. Okay. This heat and temperature, all these are very simple things, right? We know all those things, but still we had a recap. We had a good recap. That was more than enough. Now let's come to the main topic, the thermodynamics. Now, what is thermodynamics? Thermodynamics, it is the study of relations between heat, work, temperature and energy. So these are the common terms which we relate to thermodynamics, right? That is heat, work, temperature and energy, and how are they related to each other. But thermodynamics, it is also the study of transformation of heat into other forms of energy. This you have to remember. Okay, this heat, it can be transferred into other forms of energy. And vice versa. The energy can also be transferred as heat. Okay, this together we call as thermodynamics. But thermodynamics can also be used to describe the state of a gas. Okay, the main purpose of thermodynamics, you can say, where we use these to describe the state of a gas. How do we describe the state of a gas? We use certain variables. Those variables are macroscopic variables. Macroscopic variables means those variables which we can apply in our daily life. They are pressure, volume and temperature, etc. Actually many more are there which I don't want to talk about them because we don't want to go out of the portion, right? So for us the macroscopic variables are pressure, volume or temperature, by the help of which we can describe the state of a gas using thermodynamics. Now if we are talking about thermodynamics, there should be a thermodynamic system, right? That thermodynamic system, it is collection of extremely large number of atoms or molecules. These large number of atoms or molecules, they are confined with a certain boundaries. Okay, if I say that this is a thermodynamic system, the entire thermodynamic system, here all the number of atoms or molecules are present. Now this is confined with certain boundaries. Now, the speciality of these boundaries is that energy and mass, it may enter or leave the system through this boundary. Okay. And the rest portion, what all is there outside the system, is all said to be known as surroundings of that system. Okay. These three terms you should know: surroundings, system and boundary. This consists of thermodynamic system. Now, when I say surroundings means, I mean to say everything. Everything external to the system is all surroundings now. Okay. Now, there can be three types of thermodynamic systems. What are they? They can be open system, closed system and isolated system. They are the types of thermodynamic systems. What is an open system? Open system means here with the surroundings, energy and matter both can be exchanged through the boundary. Okay. Closed system means here only energy can be exchanged but matter cannot be exchanged. That means that boundary, it will not allow any matter to go inside or come outside. So here there is exchange of energy with the surrounding. And there is one more thermodynamic system. It is known as isolated system. In isolated system, the boundary is very strict. It will neither exchange energy, it will nor exchange matter with the surroundings. Okay, I hope you got it. These are the three thermodynamic systems. We talked about thermodynamics. We talked about thermodynamic system. There should also be there certain equilibrium, right? That equilibrium is thermal equilibrium. Now, what is this thermal equilibrium? A thermodynamic system, it is said to be in thermal equilibrium when macroscopic variables, we told them, right? Pressure, volume, temperature, I told etc. In that etc. you can have mass and composition also. Okay. So a thermodynamic system, it is said to be in thermal equilibrium when these macroscopic variables do not change with time. What are the macroscopic variables? We told pressure, volume, temperature, mass, composition, etc. All these, they will not change with time. That means that see, for example, you have two systems. You say that those two systems are in thermal equilibrium with each other if they will not have change in temperature. Means if they will have the same temperature. Okay. the two systems, if they have same temperature, then you can say that those two systems are having thermal equilibrium. In the same manner, you can say for pressure, volume, mass and all that also. Okay. So this is what is thermal equilibrium. What type of questions may come till what we have discussed till now means this type of question may come. Which of the following is a type of thermodynamic system? Now we know that open system, closed system, thermally isolated system, all these are thermodynamic systems, right? So all of the mentioned will be the right answer. To construct this building of thermodynamics, certain laws were laid down. Those laws were simply known as first law of thermodynamics, second law of thermodynamics and third law of thermodynamics. After three laws were stated, scientists stated another law, the fourth law, which was the basic law. So what they did, they cannot give it as fourth law, right? Because that is the more basic law. That's why they gave the name as Zeroth Law of Thermodynamics. So we have the four laws now. The first law, second law, third law and Zeroth Law of Thermodynamics. Now let's talk about them one by one, slowly and carefully, because we need to understand each and everything in this chapter. Then only we can answer the question. Any type of question comes, without understanding we cannot answer questions from this chapter. Okay. Now first law of thermodynamics. It is nothing but law of conservation of energy actually. What is law of conservation of energy? Energy can neither be created nor be destroyed. Even first law of thermodynamics also states the same. Okay. Energy can neither be created nor be destroyed, but it can be changed from one form to another form. So what does first law state here is that, see, if a body has heat energy, which we denote as Q, right? If there is heat energy supplied to that body, that heat energy, it will not disappear anywhere simply like that. It will be used by that body in two ways. It will be used as internal energy and as work done. Internal energy means the energy within the body. That is denoted by U. That we write it as delta U here. Okay, there is some change, right? If you have some change in energy, if you have change in any quantity, we denote it by delta. So that delta Q, the energy supplied to that body, is utilized as change in internal energy and the work done by that body. This is what first law of thermodynamics states. Then second law of thermodynamics states that the entropy in an isolated system always increases. Entropy means disorderness in the system. I will talk more on this with an example. Okay, here I am just giving you a glance of these laws. I will talk with more descriptions again. Okay, then third law of thermodynamics, it states that the entropy of a system, it approaches a constant value as the temperature approaches absolute zero. Then zeroth law of thermodynamics, this is the more basic law. It states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies, they are also in thermal equilibrium with each other. Now let's talk about these laws one by one with more description. First law of thermodynamics, as I told you, it is law of conservation of energy, and it states that energy can neither be created nor be destroyed, but it can be changed from one form to another. As I told you, according to this law, some heat given to the system, it is used to change the internal energy, while the rest of the energy, it is used in doing work by the system. Here delta Q is the heat given or lost by the body, and delta U is the change in internal energy, and W is the work done. Okay, this is very important law. Delta Q is equal to delta U plus W. That's why I am talking about this two times. Okay, this is a very important thing. You have to note it down. Now second law of thermodynamics. It states that the entropy in an isolated system, it always increases. That means the disorderness always increases. Any isolated system, it spontaneously evolves towards thermal equilibrium, means there is a state of maximum entropy of the system. Second law of thermodynamics, it is also known as Kelvin-Planck's statement. Means this Kelvin-Planck statement, it will talk about the same thing, about the entropy only. But they have taken the example of a heat engine. They have said that it is impossible to construct an engine which will convert heat completely into work. It is not possible, right? Heat cannot be completely converted into work. It has to be wasted or it has to be used somewhere else also. So this is known as Kelvin's Planck statement. This also comes under second law of thermodynamics. Third law of thermodynamics. It states that the entropy of a system, it approaches a constant value as the temperature approaches absolute zero. That means if your temperature is going to zero, then your entropy will not be disturbing. It will not move up and down. It will not change. It will become constant. Okay. Zero temperature means constant entropy. Means there is no disorderliness. For example, if you take a crystalline substance, in crystalline substance, no, all the things are arranged periodically inside it. That means it is having a perfect order. If this crystalline substance is at absolute temperature, then the entropy is zero. That means there is no disturbance in that crystal. This statement, it will hold true if the perfect crystal, it has only one state with minimum energy. You cannot say that it is changing the state. For example, if it is a solid, means it will be solid only. Okay, and it will have minimum energy. Minimum energy because there the atoms will not be oscillating, right? The atoms will not be vibrating. If it will have more energy, means it will not be stable, isn't it? If it is not stable, means obviously it is not at zero temperature. So that is how it is related. Now let's talk about the zeroth law of thermodynamics. As I told you earlier also, it states that if two bodies are individually in equilibrium with separate third body, then those two first bodies, they are also in thermal equilibrium with each other. Basically, this means that if system A is in thermal equilibrium with system C and system B is also in thermal equilibrium with system C, then A and B, they both are also in thermal equilibrium with each other. This is your zeroth law of thermodynamics. Okay. Now let's talk about the various thermodynamic processes. First of all, what is a thermodynamic process? The thermodynamic process means it is just a change of state of a system, but this change of system is involving the macroscopic variables change. There is a change of macroscopic variables or thermodynamic variables. What are they? Pressure, volume, temperature, mass, composition, etc. Isn't it? So, if there is any change of a system, and it is involving the change of these variables, then that process is known as thermodynamic process. Now let's talk about the types of thermodynamic process. First, the type of thermodynamic process could be the isobaric process. Isobaric process means the process during which the pressure of a system remains constant. In this process, pressure does not change. Temperature, volume, internal energy, they will not be constant. If, for example, boiling of water to steam or freezing of water to ice, other variables are not constant. Only the pressure will be constant. This type of process is known as isobaric process. Then comes the isochoric process. In isochoric process, volume of the system remains constant. Okay. For example, heating of a gas in a closed cylinder. The best example is a heat engine. We'll talk about heat engine also in this lecture only. The process happening in the heat engine is isochoric process. Then is the isothermal process. This is a process in which temperature of the system is kept fixed. Okay, the temperature does not vary. For example, the Boyle's law. If you are a HSTR aspirant and you have attended my class in HSTR time before the exam, then you will know this Boyle's law. We discussed Boyle's law, Charles' law, the ideal gas condition and all that, no? There we told that Boyle's law is pressure into volume is always constant. PV is equal to constant. So this is an isothermal process. Here only temperature is constant or pressure into volume is equal to constant. Here no, I can take example of a refrigerator. Refrigerator, it works isothermally. What happens in refrigerator? There are set of changes which take place in the mechanism of the refrigerator. But these changes do not affect the temperature inside, isn't it? The temperature inside the refrigerator, it remains constant. Heat energy will be transmitted to the surrounding environment. You can see sometimes your fridge outside the wall, the side walls, they'll be very hot. That is the reason why that heat energy is transmitted to the surrounding environment. This is your isothermal process. Next is the adiabatic process. In adiabatic process, the heat content of the system will remain constant. Remember, in isothermal process, thermal temperature, adiabatic heat. Okay. In isothermal, temperature was constant. In adiabatic, heat will be constant. Okay. During this process, heat will neither enter the system nor it will leave the system. Then there is a process called cyclic process. In cyclic process, system returns to its initial state after many number of changes. Even though changes occur, still the system will come back to its original state, the initial state. This type of process is known as cyclic process. There is a non-cyclic process also. In that the system will not come back to its initial state. Okay. In cyclic process, net work done in cyclic process is exactly equal to amount of heat energy transferred. This is important point here. The net work done is exactly equal to amount of heat energy transferred. Now let's look at a quick summary. The four important types of processes are isothermal, isobaric, isochoric and adiabatic. In isothermal, temperature of the system is constant. In isobaric, pressure is constant. In isochoric, volume is constant. And in adiabatic, heat will be constant. That is, no heat flow between the system and the surroundings. There is no change in heat energy. Delta Q will be equal to 0. There are two more very important type of thermodynamic processes. One is the reversible and the other one is the irreversible process. So what is a reversible process? A reversible process is a process that can be reversed in order to obtain the initial state of the system. Okay, you can reverse it and you can obtain the initial state of the system. Here many infinite changes will occur. Still you can achieve the initial state. That type of process is known as reversible process. Now in this process there is an equilibrium between the initial state and the final state of the system. For example, all isothermal and adiabatic changes, they are all reversible. Okay, but then you have to perform them slowly. Then only they will be reversible process. Now in contrast to reversible process, what is irreversible process? Obviously it will be opposite, right? Irreversible process means it is such a thermodynamic process that cannot be reversed in order to obtain the initial system. Okay, the initial state of a system. And here only finite changes will be occurred. So, though finite changes are occurred, you cannot achieve the initial state. And there will be no equilibrium in this system. For example, all natural processes such as conduction, radiation, radioactive decay, etc. they cannot be again achieved later, right? So, these are all irreversible processes. I am giving you the difference here only because I want you to differentiate these two processes, because any point can be asked, right? But then if you know the difference between those two processes, then you can answer it easily. That's the reason. Okay. In thermodynamics, we always plot this very famous PV curves, the pressure volume curves. You put volume in the x-axis and pressure on the y-axis. If you plot for isothermal and adiabatic process, you can see that you are getting a graph like this. Isothermal will be constant along volume. Okay, that is constant temperature, right? Constant temperature means there is no change in volume. In adiabatic, there is change in heat. That means there will be change in pressure. Okay, so this graph is a PV graph which gives you the isothermal and adiabatic nature of the system. In the same manner, if I include the isobaric and isochoric processes, you can see that along x-axis, that is along volume, isobaric will be constant. It will not depend on the volume because isobaric means constant pressure, right? In the same manner, isochoric will not depend on the pressure. Isochoric means constant volume, right? That's the reason there are straight lines here. But isothermal and adiabatic, they depend on pressure and volume. Okay, that's why the graph is like this. Now let's talk about our heat engines. Now what is heat engine? Obviously, there is some thermodynamic process occurring in the heat engine. That's why they have put this in this chapter, right? Now, what is a heat engine? Heat engine, it is a device which converts heat energy into work, and it does it continuously through a cyclic process. Cyclic process means every time the system comes to its initial state. Okay. There are three essential parts in this heat engine. One is the hot reservoir. You call that hot reservoir as source also. Okay, that same name. Hot reservoir is known as source. Then there is a working substance. The working substance is the engine itself. Then the third part is the cold reservoir. You call this cold reservoir as sink. Okay, you call hot reservoir as source. You call cold reservoir as sink. Now you can see this diagram. What is happening here is the heat is going from the hot reservoir, the heat Q1 with the temperature T1. It will go to the working substance or the engine. This engine will use this heat as work, means some part of heat will be used as work and other heat will be given to the reservoir, the T2 reservoir, the cold reservoir. Okay, the heat taken from the hot reservoir is either utilized as work or it is given to the cold reservoir which is having temperature T2. This is the mechanism of heat engine. That is only happening here. That's all. Based on how much heat is utilized from the hot reservoir and is used in doing work, we define the efficiency of heat engine. Efficiency means you can say capability of heat engine. The symbol for efficiency is eta. This eta is equal to work done upon the heat taken by the working substance. Okay, the input heat which you are giving is in the denominator, the work done is in the numerator. That eta, the efficiency, will be equal to W upon Q1. Now what is the work done? We say that the heat energy Q1 is taken and it is utilized to do some work and the remaining heat energy is given to the cold reservoir, right? So the work done will be equal to Q1 minus Q2. That's why efficiency eta will be equal to W upon Q1, or in place of W I can write Q1 minus Q2, or eta will become 1 minus Q2 by Q1. Here for Q1 minus Q2 you can divide it by Q1. You will get 1 minus Q2 by Q1. Okay. Now because temperature is directly proportional to heat, I can also write it as efficiency is equal to 1 minus T2 by T1. Okay, this is a very important formula. Eta is equal to 1 minus Q2 by Q1 or eta is equal to 1 minus T2 by T1. Okay. Now as I told you, this Q1, it is the heat input, that is the heat absorbed by the system in one complete cycle. W will be the work done on the environment in a cycle, and in a cycle a certain amount of heat Q2 may be also rejected or given to the environment. Okay, this is all I told you already. Okay. Now there are two types of heat engines. One is the internal combustion engine and the other one is the external combustion engine. What is this internal combustion engine? Means combustion of fuel will take place within the system here. In internal combustion, the name only tells, right? In internal combustion engine, the combustion of the fuel will take place inside the system. Here that pistons are used. They are used in the internal combustion type of heat engines. What are these pistons? There is something which moves up and down in the engine, right? That up and down they are moving within that cylinders. Okay, those things are known as pistons. There is also something called a stroke. What is a stroke? Means a single motion of piston. If it will go in the upward or in the downward direction, then you say that there is one stroke. Okay, single motion is one stroke. For example, many cars they have 4-stroke internal combustion heat engine. They consist of intake stroke, power stroke, combustion stroke and exhaust stroke. They are the 4. That's why they say that particular car is having a 4-stroke internal combustion. That means the piston will move 4 times, either up or down, whatever it is. Okay. Now we are not bothered about this external combustion engines. We are only bothered about internal combustion engines because in our syllabus they have given petrol and diesel engines. They both belong to internal combustion engines. Both are internal combustion engines. Okay. Now what is the difference between petrol and diesel engines? Means there are two types of cycles happening. One is the Otto cycle, the other one is the diesel cycle. The main difference between this Otto cycle and diesel cycle is that in Otto cycle, heat addition will take place at constant volume. That is, there will be an isochoric process. This is a Otto cycle. And in diesel cycle, heat addition will take place at constant pressure. That means it will be an isobaric process. That is your diesel cycle. Okay. Now Otto cycle, it is used for petrol or spark ignition engine. This you remember. Isochoric process, Otto cycle, it is used for petrol engine. Or you also call it as a spark ignition engine. Whereas this diesel cycle, it is used for diesel or compression ignition engine. You can just remember with the name only here. Diesel cycle is used in diesel engine. The other one, the Otto cycle, it is used in petrol engine. Okay. Now let's see what are the differences between petrol engine and diesel engine. Both are engines, both are internal combustion engines, but they work on different principles or different cycles. Petrol engine, it works on Otto cycle. Diesel engine, it works on diesel cycle. Here in petrol engine, no, air and fuel, they are mixed together in one chamber. You call it as carburetor. But in diesel engine, that fuel, it is mixed with air inside the cylinder. Okay. And then in petrol engine, fuel, it is ignited with electric spark. How you start your bike? You can just start with auto thing, no? That is electric spark. But in diesel engine, no, you need hot compressed air, then only you can start it. In petrol engine, the production will be very low. Petrol engine means you remember your bike. Diesel engine means you remember any truck or a bus. This is how it is. Okay. Petrol engine means light vehicles, motorcycles, cars, they use this petrol engine. Heavy vehicles like trucks and buses, they use this diesel engine. This is the working of a petrol engine. We don't need the working actually. You just see what are the parts of a petrol engine. That is more than enough for your exam. And this is your diesel engine. Also, we were talking about this petrol engine. It is a high fuel consumption. And in diesel engine, that fuel, no, it will not be much consumed. Means when compared to petrol engine, diesel engine, it will be relatively low consumption will be there. And comparatively, you will have to invest less for petrol engine. Means low initial cost will be there, low maintenance cost will be there. But maintaining these heavy vehicles like trucks and buses, it is very costly, right? So high initial and maintenance cost will be there in diesel engine. Here in petrol engine, you can see the parts of the petrol engine. It is having spark plug, air intake valve, exhaust valve, piston, connecting rod and engine casting. Whereas diesel engine is very much different. Here only you can see the fuel, the generator and the air and the exhaust. How air goes inside and how air goes outside. Only so much. But in petrol engine you have this. Why I am showing you parts means they asked in your 2015 exam for HSTR. They have asked the parts also. That's why I am showing you here. But you don't need to know the working and all that. Anyhow, we have little idea of working by seeing the differences of petrol engine and diesel engine, right? So much is more than enough. Now let's talk about the refrigerator. Refrigerator is also known as heat pump. That was heat engine. This is heat pump. Refrigerator, obviously we all know it is opposite of heat engine, right? Heat engine, it will run in reverse direction. If you make it run in reverse direction, then you will get a refrigerator. So what will happen here? There will be working substance, but it will extract heat from cold reservoir and it will utilize that heat in doing some work, and the rest of the heat will be released in hot reservoir of temperature T1. Basically, it is opposite of heat engine. Okay. Here we don't have efficiency. Here we have a coefficient of performance. The symbol for that coefficient of performance is alpha for a refrigerator. And this alpha is Q2 upon W. It is opposite of heat engine, right? There we had W upon Q1. Here it will be Q2 upon W. Because here Q2 is the heat extracted from the cold reservoir. Isn't it? That's why. And W is the work done on the system. Now by conservation of energy, whatever the heat released to the hot reservoir, it will be equal to the work done plus Q2, right? That's why the coefficient of performance alpha will become Q2 upon W or Q2 upon Q1 minus Q2. So W will be equal to Q1 minus Q2. Okay, this was all about your syllabus. This was just the discussion. Now we shall see what type of questions may be asked from this chapter. I have gathered many questions. Please watch the lecture patiently. Okay. First question is, when a body A is in thermal equilibrium with a body B and also separately with a body C, then B and C will be in thermal equilibrium with each other. Options are true, false, data is insufficient, none of this. It is true. This is Zeroth Law of Thermodynamics. Next question. The Zeroth Law of Thermodynamics states about temperature, isn't it? It talks about thermal equilibrium, right? Thermal equilibrium means same temperature. Then third question is, the two systems in thermal equilibrium with a third system separately are in thermal equilibrium with each other. This is nothing but Zeroth Law of Thermodynamics. See, these 3 questions were from Zeroth Law of Thermodynamics. But see the way how they can twist and ask you question. Okay. So, you have to learn this way. You have to see how the questions can be asked from same topic in different way. Okay. Next question. Internal energy of an ideal gas depends upon. Internal energy means it should depend on temperature. Because it is directly related to heat, right? Heat is related to temperature. There is no heat in the options, right? But temperature is there. So the option will be the temperature. Internal energy of an ideal gas depends upon only temperature. Okay, next question. Which of the following is true with regards to the energy of an isolated system? We told you, right? Isolated system means energy will be constant. Now, there will be no change in energy. There will be no exchange in energy or matter. That's why E will be constant. Next question. Which of the following process is correct for given PV diagram? You can see the graph and you can decide. It should be isobaric process, because in isobaric process no volume is having any role, right? So it is a isobaric process, because here only pressure will be constant in this process. Next question is a match the following. You have to match these. Isobaric means it should be pressure constant. Isochoric means volume should be constant. Volume should be constant means there should be no heat. No heat means your internal energy and work should be equal. If they are equal only, you will get delta Q as 0, right? So it should be isochoric 1. So A should be 2 and B should be 1. This is option A. Adiabatic, it will be delta Q will be 0 because no heat is changing there. And isothermal temperature will be constant. So option A will be the right answer here. Next question. The change of entropy when heat is absorbed by the gas is? It should be positive, because when heat is absorbed means the disorderliness in the system should increase, right? If the system's disorderliness is increasing means entropy is increasing. Entropy is increasing means it should be positive. Next question. A process is said to be reversible if, you have to see the options carefully. The process is said to be reversible if both the systems as well as surroundings return to their original states. It should go back to its initial state, right? That is only reversible process. Next question. If the temperature of intake air in internal combustion engine increases, then its efficiency will be. Intake means T1, right? If the T1 will increase means your efficiency should decrease, because it is inversely proportional, right? So option B will be the right answer. Next question. During a cyclic process, a heat engine absorbs 500 joule of heat from a hot reservoir, does work and ejects an amount of heat 300 joules into the surroundings. That is the cold reservoir. Calculate the efficiency of the heat engine. And 4 options will be given. I have not given here. Let's just solve the sum. For a heat engine, efficiency is equal to 1 minus Q2 upon Q1, right? This Q2 will be low. Q1 will be high. Whatever is low, you put it in the numerator. Whatever is high, you put it in the denominator. Here it is 300 for numerator. For denominator, it will be 500. 1 minus 300 by 500 will be 1 minus 3 by 5. 3 by 5 is nothing but 0.6, or the efficiency will be equal to 0.4. If you want to calculate it in percentage, then you have to multiply it with 100 always. Okay. So 0.4 into 100 will give you 40%. The answer will be 40% efficiency this heat engine will have. So 40% will be there in option. That will be your right answer. Okay. You have to just substitute the values. Only thing is you have to remember that you have the lower value of heat in the numerator, higher value of heat in the denominator. Only so much you remember.
Next question. The efficiency of Carnot's engine operating between reservoirs maintained at temperatures 27 degrees centigrade and minus 123 centigrade is. See, they have given two temperatures, right? But they are in centigrade. So first step to solve this problem is you have to convert this into Kelvin, right? So to convert into Kelvin, what you do? You have to add 273. But you have a minus 123, right? So it will become subtraction in the numerator, and you are using the same formula, 1 minus T2 upon T1. Okay, the greater value is in the numerator and the smaller value will be in the denominator. Okay, because T1 is low and T2 is high. Okay, so you just substitute, you get 0.5, and then again in order to convert efficiency into percentage, you need to multiply it with 100 and you get 50% as the answer. Okay.
Next question. The temperature of sink of Carnot engine is 27 degrees centigrade and efficiency of engine is 25%. Then the temperature of source is. Here you have to find something different. Efficiency is already given, right? Efficiency is given. You have to find one of the temperature of the source. Just substitute the values and you have to simplify here also. Okay. Here option C will be the right answer. 127 degrees centigrade. Okay. Next question. In a petrol engine, if diesel is used, then the engine will not run more efficiently, run at high speed, explode. It will not run. Because it is a petrol engine, right? It will not use diesel. It will use only petrol. Next question. A diesel engine as compared to petrol engine is, it is more efficient, less efficient, equally efficient, other factors will decide it. No. Diesel engine, it is highly efficient when compared to petrol engine. So option A will be the right answer. Okay, next question. Piston ring are usually made of. Means they are asking you the material with which the piston is made. You should just know it. Just a GK you think. It is made of cast iron. Okay. Next question. Which of the following is not an internal combustion engine? Of course, diesel engine, petrol engine, all types of petrol engines, they are all internal combustion engine. So the engine which we have not studied and which is not internal combustion is steam turbine here. Okay, maybe that is our external combustion engine. Now let's talk about the Stephen-Boltzmann law. Actually, Stephen-Boltzmann law they have not particularly given in your syllabus, but they have asked one question from this topic in 2015. That's why we don't need to take any chance. I thought I'm just speaking little bit. I'm giving you just a gist about this law. I will not go into much deeper. This Stephen-Boltzmann law, it describes the power radiated by a body that absorbs all radiation that falls on its surface. Okay, this power radiated, no, it is in terms of its temperature, or in other words you can say that the radiation energy per unit time from a black body, it is proportional to fourth power of the absolute temperature. The heat radiated is Q, right? Q is equal to, or Q is proportional to T to the power 4. You remove this proportionality symbol and you add one proportionality constant. That constant is known as Stephen-Boltzmann constant. You write it as sigma. The symbol is sigma. So Q will become sigma into T raised to 4. This T is absolute temperature. Okay. There is this value of this Stephen-Boltzmann constant also. It's better you remember this value and the unit also. It is 5.67 into 10 raised to minus 8 Weber per meter square per Kelvin to the power 4. Okay. The question was like this. If the temperature of a black body is doubled, then the amount of heat radiations emitted per second is. So with this law, we know that Q is proportional to T to the power 4. So if the temperature of the black body is doubled, then the amount of heat radiations emitted will be 2 to the power 4 because doubled, right? So Q will become 16. Here don't worry about black body. Black body means it is that body which will keep all the wavelengths inside. It will not reflect anything. Okay. If it will reflect, it will have become white body, right? It is a black body. We take that black body as an ideal body. It doesn't exist actually. There is no black body which is perfect. There is no perfect black body existing. We just take it as a ideal, like the ideal gas. There is no ideal gas, right? But we take it typically, we assume it typically to study, right? It's like that. Okay. Now they can ask you some few common questions also like this one. When ice melts, its temperature remains what? We can say it will decrease or we can say it will increase. But sorry, both of that will not happen. It will remain constant. Why? Here is the answer. The temperature of the ice, it will not change during melting because heat energy given to that ice is utilized totally in breaking the bonds between the water molecules. Okay. That's why when ice will melt, its temperature will remain constant for some time. Okay. At least for some time it will remain constant. Then the temperature will vary because the system will not be isolated, right? isn't it? The heat from the surroundings, it will try to come inside the system. That's the reason that why the temperature will change later. Okay. So this was all about your chapter thermodynamics, and believe me, this is more than enough for your HSTR and CRIS and Karnataka TET, Common TET, KV, all the teacher recruitment exams. This is more than enough. Okay. I hope that I helped you, and please do like, share and subscribe to my channel. And this class was little bit slow. Don't mind. Why I kept it slow? Because many people cannot grab the fastness of my class, right? This particular chapter, it needs little consistency to understand. That's why keeping in mind all the type of aspirants who can grab easily, who cannot grab easily, all the type of students, I kept them in mind, and then I am recording this class. Okay. Okay. All the best. Bye.